In this video, I will practically wire a lighting point in such a way that at the end of the video, wiring a lighting point will be clearly understood. So, if the video is found useful to you, please consider subscribing to the channel. Thank you. Now let us look at the items involved in the wiring. These are neon testers. They are very good for usage on electrical circuit. They are called neon lamp tester because they have a neon lamp inside that indicate the presence of voltage whenever there is contact with voltage. And this is a plier for cutting cable and for peeling cable. Now, this is a lamp holder which is at an angle of 45 degrees to the line of sight. Alright, it is a 3-pin lamp holder. It has a neutral, live, and the air terminal. This is an LED bulb. It is a 15-watt LED bulb. LED means light emitting diode. This one is rated 15 watt and it operates at 230 volts. And this is a energy saving bulb. It's different from this one. This one is LED, light emitting diode. This is energy saving bulb. The two of them, they have power factor components. Alright, so they are different from incandescent lamp that has a power factor of 1. This is a 10-amp switch. So this is the position of the switching position rather. So in order to see what is inside, one we need to open this cover. This is how it is. This is the common terminal, and these are other terminals. It's a two-way switch, but in this case we are using it as a one-way switch. So the connection will be made to this terminal and this terminal. This is the incoming terminal and this is the outgoing terminal. This one goes to the load, while this one is from the voltage supply. So these two provisions, the holes that are here, they are for screws that will go and hold the base to the switch itself. So that's it. And this is the base, the switch, or for the 13-amp socket. So in installing it, you have to be mindful of the location of these two screw positions. They should be sideways, not this. It is better this way, because the cable is either cable comes in or goes out through this place, or through this place. This one, there is a kind of hacking here to allow for cable to go in or to go out. This is the supply item, this is where voltage will be tapped. It's expected to have been in existence. So for the purpose of this one, it's expected that it is already pre-wired or is in existence. You just tap voltage from there. It serves as a source of voltage, but for purpose of explanation, I'm bringing it up to be seen. This is the earth terminal, and then we have have the neutral terminal here and the live terminal here. So they are marked. All right. When this is the switch. This terminal to the right is the live terminal. This is the why this one is the neutral terminal, and this is the earth terminal. So when the switch position is in this place, there is voltage supply available at the terminals here. And this is a 13 amp plug. So this is the live pin, and this is the neutral pin, while this is the earth pin. And when it is opened, this is what will be seen. This is the fuse, and these are the terminals, the earth terminal, the neutral terminals, and the live terminals. It's still the same live terminal that is connected to this pin. That's why this pin here is the live terminal, live pin, while this one is the neutral pin, and this is the earth pin. So the fuse will be replaced with 10 amp fuse in order to be compatible with the 1.5 mm PVC copper cable that we are using for the purpose of this wiring. So we cover it back. This one is to be plugged into the 13 amp socket, and this one is the plug that will power the lamp that we are using as load in this wiring. And this is connector. The connector is used in joining two cables, right? Yeah, and it can withstand 10 amps. They have a current rating. You cannot just take any type of connector. This one can withstand up to 10 amps and even slightly more. And this is a clip for holding cable. So the nail is the nail goes down into the wiring board to hold the cable. And this is a screw to be used where it's necessary. In most cases, to hold the base of the switch or the socket to the wiring board. This is the screw for holding the switch to the base of the switch. And very important, this is the cable. This is 1.5 mm square 3-core PVC copper cable. So it is going to be cut into appropriate length during the wiring. As I said, when the cable is cut, these are the three cores, or the three cables inside. This is the conductor, that is the copper conductor that is appearing inside the insulator here. So this is the live. This brown will be used for live, this one will be used for neutral, and this one will be used as the earth cable. So this is green and yellow. In some cases, this one, instead of being blue, it could be black, but we are using it as a blue here based on the availability of the cable that we have. The next thing is the termination of cables on the fittings, and let's go. This is the switch socket, 13 amp switch socket. As I said, it's supposed to be in existence. It's supposed to be an existing item. is just supposed to serve as a footage source. I'm just showing it for illustration purpose, especially as far as this wiring is concerned. So you look at it. This is the life, the neutral, and the earth. So there's one thing you will notice here. The cables will be peeled in such a way that the conductor does not get exposed after terminating it, each of them. So that this is the proper way of doing it. So this one will be put on top of the base, and then we have a very neat circuit arrangement. So, and as I said also before, this cable is 1.5 mm 3-core PVC copper cable. It is PVC in the sense that if we look at this one, this is one of the cables. This is the conductor. We have PVC material here covering the conductor, and we still have the overall PVC material covering the three cables. That's why we have PVC. So it's 3-core 1.5 mm square PVC copper cable. So that's this. Now we look at the switch. This is the switch. All right, and when you look at it, by the time we finish this the termination, we are going to screw this faceplate down to the base. Then let's look at the termination. This is the live. This is also live. It's only the live cable that needs to pass through the switch, or the live conductor. It is only the live conductor that needs to pass through the switch, and that is why the head cable, the two sides are joined together, making use of this connector. The same thing for the neutral. We don't insert the switch into the neutral line, because it's the live line that we insert the switch into, so that one will not receive shock the moment the switch is in the off position. Here it is. This is the lamp holder. We have the live, the neutral in blue color, and the earth in green and yellow color. So that is the situation here. So, and again, the conductors are not showing after they are terminated. Now we look at the plug. This is the plug that will go into the socket. This is the fuse, 10 amp in this case, or in this situation. And this is the earth pin or earth terminal, the neutral terminal, and the live terminal with the fuse. This is the fuse. So we need to tidy up everything. Now we move on to the wiring board and see the complete wiring arrangement, and we see the complete circuit. Moving on, the base of each of the fittings should be mounted to the wiring board first accurately, and this is the base for the 13 amp socket. This is the base for the 10 amp one-way switch, and this is the lamp holder. This is the cable, and this is the clip to hold the position to hold the cable in position. All right. So now the next thing is to tighten the screws properly. Okay. Finally, this is the complete wiring or the complete circuit. This is a power supply cable to our source fitting. Our source fitting here, or power supply or voltage supply fitting here, is the 13-amp switch socket which you can find around. From there, we have a connection to the switch, from the switch to the lamp holder and the bulb. This is 100-watt bulb, incandescent bulb. Alright, and the power factor is 1. So that is the situation. And then the cable. This is 1.5 mm square, 3-core PVC copper cable. Alright, and then the next thing is testing. We can test it. So we switch on the 13-amp switch socket first. Okay, then we switch on this one. Alright, and that is it. The bulb can be replaced with another type of bulb. Alright, but before we do that, we switch off, then we do we change the bulb. We put this one there, put this one there, then you switch on. This is 26 watts energy saving bulb. You can see that it's brighter, but in this situation the power factor is not 1. It is less than 1. It's around 0.6, depending on the manufacturer. We can still use another type of bulb to test it. Switch off, and then alright, this is a 15-watt LED bulb. You can see that it's brighter, very bright, and the power factor is not 1, it's less than, the power factor is less than 1. So that is the situation here. The voltage supply to our voltage source here is 230 volts at 50 Hz, and that is the situation. Is what can be done easily. Thanks for viewing, and please, if you find the wiring useful, please consider subscribing to my channel. Thanks for watching.